Hi guys, Blackbox here. Another little tutorial video for you guys. This time we are talking about departure and arrival procedures, especially using the FMGS. There are a lot of airports that have special departure and arrival procedures, especially when it comes to altitude and speed restrictions. But if you know how to use the flight management guidance system correctly, then even very complex arrival and departure routes can become quite easy. So let's get started, and we are doing a flight from Munich to Frankfurt, and I'll show you the routing right now. We're taking off runway 26 right. It'll be the Give Me 1 November departure, which obviously ends at Give Me. Then we have the Yankee 101 all the way to RNAV, and then it's the Tango 161, which ends for us at Aspat. And after that we'll do the Aspat to Whiskey arrival route for runway 25 left. And as you will see later on, the Aspat to Whiskey arrival is a somewhat more complex and very interesting arrival route. But first of all, let's have a look at the departure route. Give Me 1 November. So here's the chart. I can see Give Me 1 November as with the identifier. And so we'll take off runway 26 right, fly towards Delta Mike 060 with a maximum speed of 220 knots. At that waypoint we turn right, proceed to Delta Mike 063. Maximum speed at this waypoint is 250 knots, and after that we will proceed another right turn towards the waypoint Give Me. Now looking at the text information for that departure route, we can see, for example, it says the departure frequency is 123.9er, and we should call that when instructed by the tower. Another important information is the initial climb altitude, flight level 70. It doesn't always show that on the departure charts, but in this case it does, and so we've set that already in the FCU. Whenever we want to fly a departure route according to FMS, we need to check the waypoints in the FMS and compare those with the chart waypoints. Also, we have to check the speed and level restrictions that might be imposed on those fixes. So in this departure we can see that we have two speed restrictions, Delta Mike 060 maximum 220 knots and Delta Mike 063 a maximum of 250 knots. And those are correctly programmed in the FMS. Below the frequency 123.9 you can see two so-called ball nodes, and you have to scroll all the way down to the bottom part of the chart and then read through those nodes. So 1 and 2 are applicable for us regarding parallel departure in progress, and also that we need after 15.2 dmi Valda the B RNAV equipment. Before we go any further, let's have a look at the definition of RNAV. Now in the beginning, RNAV had its name from random navigation, and nowadays it's called area navigation, and it just simply means that you're flying along a track which is independent of any ground-based VOR or NDB stations, and is defined by so-called fixed positions. This of course means that you can navigate directly to any given fix, and that leads to a reduced overall track distance and also a less congested area of airspace. Now be aware of the fact that RNAV does not require a GPS to be installed in the aircraft. What is required is that the aircraft's actual navigation position, or the ANP, is equal to or better than the RNP, and the aircraft's ANP, the actual navigation position, depends on the quality of the updating systems. And of course, if you have a GPS, then the ANP of the aircraft will be very high, very good. But nevertheless, the aircraft's position updating can also be done by the inertial navigation system or by using an updating from VOR DME or to DME stations. Now, different areas require different RNPs, and so, for example, RNAV 1 is also known as PRNAV, and that stands for the fact that the RNP has to be 1 mile or better, and is usually found within the terminal area of an airport for departure and arrival procedures. And in the terminal areas where you have RNP1 or RNAV1, the aircraft's ANP has to be at least 1 mile or better in order to operate according to RNAV procedures. And so you can think of it this way: an ANP of 1 is described by a circle around your aircraft with a 1 mile radius. And so even if the aircraft has a so-called position error of up to 1 mile, it is assured that the aircraft actually stays within that corridor of 1 mile left and right of the desired path. Likewise, if the ANP, the aircraft's actual navigation position, is estimated to be more than 1 mile, then this cannot be assured anymore, and in this case the aircraft would not be able to do RNAV 1. And should this be the case, then you would have to fly a conventional departure route or arrival route, or get radar vectors from air traffic control. And just in case you're wondering, conventional means by navigating through VOR radials and DME distances, or via non-directional beacons. Last point I want to note is that for RNAV approaches, the RNP is usually 0.3 nautical miles. Be aware that the FSLabs A320 MCDU displays the required navigation position, and this changes sometimes depending on the flight phase. So for example, if you're doing an RNAV approach and you activate the approach phase, then the RNP will change. However, that doesn't mean that it actually changes to the correct value. So for example, here it changes to a default 0.5 nautical mile RNP. However, for the RNAV approach, you'll need to put in 0.3 as the RNP. And that way, if the ANP goes above the RNP, so above 0.3, then you would have to discontinue the approach. Also, if you have a system failure, like in this case all the 3 IR systems fail, the aircraft is not capable of calculating its actual navigation position anymore. And in this case also you would need to discontinue the approach. For departure and arrival, whenever you cannot meet the required navigation position, you would need to fly via conventional means, i.e. VORs, NDBs, etc. Or you could get the radar vectors from air traffic control. And who knows, this might come in useful sometime when you're flying on IVAO or VATSIM. Now of course these principles also apply to other aircraft types. But let's get back to our flight from Munich to Frankfurt. So we pretty much finished all preparations. Just before departure we'll check again that the required RNP of 1 mile is actually being met by the system. And so on the right side, the estimated navigation position, which you can equal to actual navigation position in this case, is 0.09 nautical miles. So that's all good. And we can fly the departure route according to FMS. Almost forgot. you will come across three different kinds of departure routes on the charts. You have the so-called RNAV departures, the RNAV overlay departures, and also the purely conventional departure routes. Let's start off with the RNAV overlay departures. You can fly those either via flight management guidance, computer guidance, or conventionally according to the described text. So either you have the waypoints which you check with the FMS, or you do the setups with the navigation aids and then fly the departure route totally conventionally. Both of those are possible with RNAV overlay departures. Now, of course, with a pure RNAV departure, RNAV SID, you obviously do not have the option to fly it by conventional means. So you only have programmed the waypoints that you have to navigate to, and usually on the bottom there with a ball note it says something about if unable RNAV, then you have alternative means. In this case, in Oslo, for example, there's something called omnidirectional departure available. So to sum up, you're able RNAV departure if the required navigation position is being met by the aircraft system, so ANP equal to or better than the RNP. If that is not the case, if you have a failure of some systems that mean that the RNP cannot be met, then you would have to revert to conventional means or to ask ATC for radar vectors. Okay, so let's take off. Manflex 65 SAS runway and out of thrust is blue. Rotate. Positive climb, gear up. Thrust climb, climb out blue and out of thrust. Autopilot 1. So as we briefed, first restriction at Delta Mike 060 is a maximum speed of 220 knots. Now, since we are in a managed mode, the autopilot will automatically respect that restriction. So we can see the second restriction here at Delta Mike 063, 250 knots or below. And also we are approaching level 70. Just watching the level off. Alright, so let's continue our climb. Gonna climb up to level 150, and again I'm pushing that altitude knob in order to stay in the managed climb mode, and that way the autopilot will obey any altitude and speed restrictions. And if it cannot meet those, then we'll get a message regarding that. Also, in the managed mode, the speed is orientated according to the econ speed, meaning that it is the most economical climb speed. And the same goes later on for the descent. Try to fly it managed as long as possible in order to save fuel. Right, we can see we're approaching Delta Mike 063 and the autopilot is still maintaining 250 knots. And even if we were above level 100 right now, the commanded speed would stay at 250 knots. And that will be the case until the aircraft passes Delta Mike 063. Actually, you can still see it now. We're above level 100, still maintaining 250 knots, and just waiting to pass that fix. And now at almost level 110, the higher climb speed is commanded. Right, we're approaching level 260, and as always, the last 1000 feet to level off, we try to climb with a maximum climb rate of 1000 feet per minute. And that is to avoid inducing any traffic resolution advisories if there's any aircraft flying 1000 feet above us. So we'll just do the level off and then we'll have a look at the approach, because we're also approaching the point Aspat, and so we have to fly the Aspat to Whiskey arrival, and as mentioned earlier, it is a somewhat special arrival route. The Aspat to Whiskey arrival route was implemented in order to see if implementing a routing with fixes that have correlating altitude windows that the aircraft has to fly through actually helps to lower the frequency congestion. Also, it is implemented in order to help the aircraft fly a more economical continuous descent profile. Now, you as the pilot, you have to make sure that the waypoints with the given altitude restrictions are actually correctly programmed in the FMS. And so you have to go through the FMS and check each waypoint right until the point Spessart in the arrival route. And of course, these restrictions are also displayed on the navigation display. Oh, and one more thing, you have to program the Aspat to Whiskey via the ILS first of all, then the approach page, and then very important, go to the approach via page and then select no via. Otherwise you will have a wrong transition after Spessart inserted. So the clearance would be something like Edelweiss 522 via the Aspat to Whiskey arrival, descend and maintain flight level 110. So what we do is we insert level 110 into the FCU and then press the altitude button in order to have the managed descent again. And now you can see that the aircraft is planning its descent according to those altitude windows and trying to get an optimum descent path. So the deviation vertical deviation now almost reaching 0. You can see that with the magenta circle in the altitude window. And all we do now is watch and make sure that the autopilot is working correctly and is actually hitting those windows correctly. As you can see, passing DDOM at level 240, right on a dot. And so now the next window is Zirpo between level 160 and level 150. In order to stay within the optimum path, i.e. trying to keep that circle centered and keep the vertical deviation close to 0, the autopilot will, if necessary, reduce the sync rate and also allow the target speed, in this case 262 knots, to drop down towards the lower limit of that speed window. Alright, I'm going to zoom forward a little bit, and here you can see that the speed is now getting close to the lower limit. Thrust is still idle on path. Nevertheless, the auto thrust will kick in very shortly if the speed drops down further, in order to just speed up again towards the optimum descent speed. And there we go. Now the mode has changed to speed, and thrust is added in order to get back to the roundabout 262 knots. So we have 8 miles to go until Zirpo and about 2,000 feet to lose to get into the window. So it's looking pretty good. And again, reaching the optimum descent speed, and the auto thrust is commanding thrust idle. Right, approaching Zirpo, and again, looks good that the autopilot will exactly hit that window between 16 and 15,000 feet. We have passed Zirpo, and now the next window becomes active. Lepsa level 130 and 120, and after that Spessart at level 110. You can see that the aircraft is planning to exactly reach level 110 overhead Papa Sierra Alpha. And again, reaching Lepsa, reaching 130, and of course, once past Lepsa, the next target, 11,000 feet of flight level 110, becomes active. You can also see that the arrival route after Spessart continues via those programmed waypoints and ends at Delta Fox 616, at which point, or the latest point, that you should expect radar vectors for the approach. Since we are approaching Spessart, it's about time to get the weather data and feed our performance approach page. Right. Also at this point, it would be a good idea to check the present navigation accuracy. And you can see here it is high, and so we can still fly the arrival according to RNAV. Just watching the autopilot now approach Spessart and maintain level 110 when reaching. And here we are, Alt Star, leveling off perfectly over HBS at level 110. So present weather in Frankfurt is quite good. We have winds 250 at 8, cav OK, 19 degrees, and the QNH is 1017. So we'll put that into our approach page. And also not forgetting the minimum descent altitude. In this case it is 570 feet. Last but not least, we'll set him some nav aids, Fox Mike on nav 1 and Charlie Hotel Alpha on VOR2. And we have a beacon also, Foxtrot Romeo, and we'll set that on ADF2. Now, what can happen if you're flying on something like Iveo or VETSIM? You could actually get suddenly some radar vectors, so you're leaving the arrival routing and you're being radar vectored to the final approach course. So let's pretend we're getting a clearance turn right heading 340. And also a descent clearance down 5000 on the QNH 1017. Next, let's put in a extended centerline out of Letke to help us orientate ourselves. So we'll go press direct to and then look for the point Letke, and then we're gonna have the radial in, which is the opposite from the inbound course. So in this case, so the inbound course is 248 and the opposite will be 068. We'll insert that into the radial in prompt, direct to insert, and then don't forget to pull the heading knob one more time. Otherwise the FMS calculates an inbound intercept track, which you don't want. Now we are too high, we have about 22 track miles and still over 8,000 feet high, so we're gonna have to use the speed brakes. And if you select full speed brakes with autopilot on, the speed brakes will not extend fully, however. In order to achieve this, you have to switch off the autopilot, and then you'll see that the speed brakes will extend fully. So we're getting the clearance, heading 280 and cleared the ILS runway 25 left. Here we have lock star, glide slope star. So we're approaching the correct glide path a little bit fast, so we'll reduce the speed. But you can see the speed brakes are pretty effective in manual flight and fully extended. So we are getting established now. We can retract the speed brakes again and start configuring the aircraft. Flaps 1. Setting now the go-around altitude of 5,000 feet.
2,500.
Selecting flaps 2. Manual thrust. Gear down. Gears down, selecting flaps 3.
2,000.
And then flaps full. Last thing to do is arm the spoilers. And so the landing checklist, EK-Memo landing, no blue. And now we try to get the aircraft stabilized on the glide path, on centerline, and on speed. The latest point at which to be stable is usually 1,000 feet above the ground, or the threshold of the runway. So we have about 500 feet to go. It's checked and the aircraft is stable. Selecting gear down. Flaps 3.
2,000.
Flaps full, and then we'll arm the spoilers. Everything's done. We can read the landing checklist. So we have EK-Memo landing, no blue.
1000. $500. 400. 300. 100 above. 200. Minimum.
Continue.
100. 50. 40. 30. 20. Retard. 10. 5.
Alright, smooth touchdown. We have spoilers, reverse green, and decel. Alright, we're coming to the end of this video. I do hope you have enjoyed it and maybe learned a thing or two about RNAV. If you still have some questions, or if I did miss something important, then leave a comment down in the comment section below. Until the next video, as always, take care, happy landings.